All right, so in this video, I'm going to talk a little bit about how pointer arithmetic works. So I'm going to be using this online gdb.com, which is a really helpful editor that you can use to write and debug code in real time. All right, so let's start by creating ourselves a character array. So an array of characters in C++ is called a string. So I'm going to write out this char name 30. I'm actually giving it more space than I need because the string's only going to take a limited number of space. So I'm going to write out char name. Let's just create that as an empty array right now. We're not going to initialize it with anything. And when I do that, C++ is just going to put it on the stack. And it's not going to initialize it to any particular value. It's just going to be whatever's on the stack. All right, so let's print out what we see. So in this case, we're just going to see, all right, it prints out nothing. But that's not always going to be the case because it's just going to be whatever's sitting on the stack. So in general, that could just be junk data. So we always want to initialize it. We always want to initialize this name value or any of our arrays with a manual initializer so that we can know they contain valid data. All right, so let's go back and do that. So I'm going to initialize it with a constant string, your name. I misspell it here. And the way that C represents strings is basically as character arrays, where each index in the array is a character, and then the array ends with this special marker named 0. And we'll see how to manually create a string by creating a character array later. All right. So let's just now show the fact that we can now do name and then index at an individual character. And this is just going to say grab the 0th element of the array. And that is the letter Y, because that's the first letter in the string. So arrays start at their base, and then as they grow up, each subsequent character is the next character in the array. All right? So we can take a pointer also to the first element of the array, because arrays and pointers are basically the same thing. If I assign a pointer to an array, that just means give me the base address of the array, right? The array is always stored somewhere in memory. In this case, because the array is a local variable, it's stored on the stack. And so here, name again is going to be a pointer to that place on the stack that stores the first element of name, and then it has 30 things above it that are going to store all that information. So I can see when I see out name again here, it's just also going to be your name. And then, of course, that Y there that gets the 0 index. All right. So let's go add more stuff. Let's do some pointer arithmetic now. So we can increment a pointer to point to the next element in the array, or in general, the ith element, sort of off from that base of an array. Now, pointers and arrays are basically the same thing in C, right, in C++. So if I take name at 2, then I can just take name plus 2. And that will be the base address of the array plus 2 elements. And C++ knows how to figure out what that address is because it knows the size of a character. So it can take the base address of name, and then it will add 2 elements to get that next address there. And then because C++ treats strings as arrays of characters, well, if I go to my index 2, which starts at U, R, N, A, M, E, then C++ will print it out like that. All right? All right, so next, when we add to a pointer, what we're really doing is moving that address up by some number of elements. All right? Now, in this case, it's going to be whatever that base address is plus I bytes, because the size of char in C++ is always defined to be 1. That's something that's universal across implementations, and it's in part of the standard. But in general, if we have an array of, for example, doubles, and I take a pointer to a double and I add 3, well, it's actually going to add 3 times 8 bytes, because the size of a double is 8, at least on my machine. This can vary. So in C++, when you print a char array, it is regarded as a string. Right? So we can actually make these manually ourselves. And this is called a C-style string. right? There are other ways you can represent strings. For example, if you want to print out characters in Japanese or emoji or something like that, they aren't going to fit in a single byte, so you need another kind of representation of strings. So this is just one particular kind of string, a very old kind of string. We're going to call it a C-style string. So I'm going to write this array right here, where I'm going to say char manual name, and then I'm going to give it, let's say, 5 elements. And then I can say the first element is k, the second element is r, the third element is I, then s, and then 0. And then the last element of that array has to be 0, because that's a marker to C and C++ applications that that's the end of the string. If I just give you a pointer and I don't tell you how long the string is, there's no way to discern. So by convention in C and C++, we represent these C-style strings as arrays of characters that end with the number 0. Right? And in fact, each of these characters is in fact an ASCII code. So I could go look up that element as a decimal value and write it there instead of, for example, writing k. Now we can also change elements at pointers. Just like I can say manual name at element 1 equals, let's say, O. And then let's print that out. Manual name, indel. Run that. Just like I can do that, I can also increment the pointer as well. All right, so note here that this is the exact same thing as saying manual name plus 1, all of that star, because I want to write to the pointer, equals O, R. And if that doesn't make sense, I'm going to refer you to the C++ tour, where pointers are explained there. All right, so now I can see where I first set it to KOIS, now I'm going to reset it by using this notation here. All right, and then I can see the name goes back as I would expect. All right, and in general, this is because if I have some pointer, so for any array where I say ARRX, that's the same thing as saying ARR plus x equals, and then I have to pointer assign to it. So you can assign to it by saying PTR and then that. So that's raw pointer assignment. Right? So you're just saying, here's a pointer, set that value there. All right, good, thanks.